Welcome to this video where we are going to discuss 3.1b, domain and range of continuous functions. Our essential question is, why are domain and range important in defining a function? And by the end of this video, you will be able to identify the domain and range of a continuous functions using interval notation. Function. Remember, a function is one-to-one. Every input x only has one output y. The inputs are your x values, the outputs are your y values. No domain repeats in order for a relation to be a function. Domain and range using interval notation. Here's some key things to take notes in your note sheet. Brackets. We're going to be using brackets. These are the square brackets. So notice how they have a distinct little box that we need to use with practice. And this is when an endpoint is included in the interval. Parentheses, we'll use parentheses, so those are the curved ones. We will use those when the endpoint is not included, when we see an open circle in the graph, or when infinity is involved. And we'll talk more about these details later. Infinity, when something goes on forever, it's a little sideways 8 is the symbol for infinity. It's always represented with parentheses, never use the brackets. The brackets are only for when there's a stop and the endpoint is included using a closed circle. Your smaller value is going to stay on the left, larger on the right. Examples. So if we're looking for the domain, the x values in a function, you might see something like this. This means it goes to negative infinity on the left side, and it stops at 5 on the right. So extends forever left, and it stops at 5 for the x value where the 5 is included. Remember, the brackets tell us that it's included. The range, you might see something like this, where we have a parenthesis with a 0. That means that it excludes 0. There's an open circle at 0, and the graph will travel up forever. So where the y value is 0, there's an open circle, and the graph travels up forever, which is why it goes to positive infinity. We'll look at graphs and what this looks like in a few examples here in a moment. Remember, continuous versus discrete. Continuous, there's no gaps between the x values. Line or segment is continuous. Discrete, the x values are not connected. There's gaps. Then it's discrete. Vertical line test. We can use what's called the vertical line test to see if a relation or a graph is a function. Any vertical line drawn in a graph crosses the graph more than once, the relation is not a function. If, however, every vertical line drawn crosses at most once, so only one time, then it is a function. So for example, if we look at this first graph and we draw vertical lines, notice how every vertical line, it crosses once, once, once. There's no vertical line here where it's crossing more than once. Therefore, it passes the vertical line test, which means we can say, yes, it's a function. Moving on to this example, if I draw a vertical line, crosses once there. When I get here, notice that it crosses 2 different points on the same vertical line at 2, 2, and 2, negative 2. This fails the vertical line test. Therefore, it is not a function. What we've talked about before is when the x values repeat, not a function. So this is not a new concept. It's just maybe a new looking at a graph and doing a vertical line test to see how if the x values repeat. Use the graph. Is this graph continuous or discrete? This graph is continuous. The domain, if we use our interval notation, the domain, again, we're looking for the x values. So if you think about where the graph starts, the x value here is at 0. Therefore, this graph starts at 0. We use a bracket to say that 0 is included. And it travels to the right. It's going forever, which means it's it's not going to stop. We're not going to have a bracket that's going to stop it. It's going to go on forever to positive infinity. You can leave it as infinity. You can put a little plus in here if you want. Does not matter when we use positive. We'll always assume positive if there's no plus or if there is a plus in there. The range. Got ahead of myself for a second. The range, we're looking for the y values. Now we're looking at the y-axis. And if you see this point, the coordinates are 0, 1. So the y value is what we're interested in the range. So this graph, the y value starts at 1, and 1 is included. And the graph travels up, which means it goes to positive infinity. Is this a function? Well, we can use our vertical line test, see if it crosses more than once. It does not, therefore it passes, and yes, it's a function. Let's try another example. Continuous. This graph does not have any gaps between the x values. Domain. If we look at this, we have an arrow that's traveling left forever, and it's also traveling to the right forever. Therefore, it's going to go all numbers, negative infinity to positive infinity. Another way to state this is we can say all real numbers. And a symbol for this is 2 lines, and you make a little R. This means the same thing. All real numbers, here's the symbol for it, and this would be what the interval notation looks like. It's negative infinity to positive infinity. It does not stop. The range, for doing the same thing, again, you see the arrow, it's traveling up in the y direction forever, and this one's going down forever. So therefore, it's going from negative infinity to positive infinity. We check to see if it's a function. We can draw our vertical lines. It passes. Therefore, it is a function. Continuous or discrete. You see how there's gaps between these? Therefore, this is a discrete function in which we're going to list the domain by going across to each x value. So if I start here, the x value is negative 2. X value here, negative 1, 0, 2, and 3. And then we go to the range. I'll start at the bottom. Negative 3 for the y value. Then we're at negative 1, 0, 2, and that y value, that is incorrect. That y value up there is up at 5. Apologies. Let's change that. And we're looking to see, is it a function? Well, if we draw vertical lines through these points, there's only one point on each vertical line. Therefore, this passes our vertical line test, and it is a function. Continuous or discrete. This graph is continuous. There's no gaps between those x values. If we use our interval notation for the domain, we're looking for the x values. This x value is at negative 5 to positive 5. And so if we use our interval notation, remember when there's an open circle, we're going to use parentheses to indicate that negative 5 is not included. And if we go here to positive 5, we can use our bracket to stop it at 5. So the x values go from negative 5 to positive 5. The range. We look at the bottom here. The range is at negative 2. Negative 2 is included because those points are included. So we have negative 2 at the bottom, and if we go to the top, we're at positive 2. Both of those values are included, so we're going to use brackets. And now we can test our function vertical line test, and notice that it passes. Therefore, it is a function. Remember, open circle, we use parentheses, which means the point is not included. Closed circle, we use brackets, which means it is included. Let's check this one. Is it continuous or discrete? It is continuous. For the domain, if we're using our interval notation, we look on the left. The x value here is -4. It's an open circle. Therefore, we're going to use a parenthesis. And the graph travels to the right forever. Therefore, it goes to positive infinity. For the range, now we're looking at the bottom of the graph, it looks like. Because I see this arrow pointing up, there's got to be a bottom of the graph. And the y value here at the bottom is a +1. So 1 is included, and the graph travels up forever, which means it goes to positive infinity. Do our vertical line test. It passes. Therefore, it is a function. Remember, open circles, we use parentheses. Closed circles, we use the brackets. One more example, continuous or discrete. This one is continuous. If we're using our interval notation for domain, we look on the left. Looks like this graph starts at 0. It's included, so we use our bracket, and it goes to the right, which means it goes to positive infinity. The range, it's going down forever. So that arrow is pointing slightly down. If we think of the y direction it's going down forever. It's going to negative infinity. And this one's going up forever, which means it's going to positive infinity. Now we test our vertical line. Looks like it fails because it crosses here. There's 1 point, and here. So at 1, 1, and 1, -1. This graph fails, therefore it is not a function.